There are different types of user-defined functions that you can write. I'm going to say that the categories are, first of all, the kind of function that calculates and returns just one value. We also have functions that calculate and return more than one value. And you have functions that don't calculate or return anything. They just do something. They just accomplish a task, such as printing or displaying. And again, they don't return any values. So in a sense, this is arbitrary, these categories, but in a sense they are different in a couple of ways. One is the way in which they're called, and the other is what the function header looks like. Now for all functions, regardless of the type, the function definition is going to consist of the function header. The function header always has the reserved word function. And then if the function is returning anything, you have an output argument or a set of output arguments and the assignment operator, but only if the function is returning something. And then you have the name of the function, which is always the same as the name of the M file, and whatever input arguments you have to pass to the function. Then underneath the function header, you have a block comment describing what the function does. And then you have the body of the function, which includes statements. And that includes putting values in all of the output arguments if the function is returning anything. And then you have the word end at the end of the function. So that's the case with all function definitions. So let's take a look now at the kind of function that calculates and returns more than one value. So this is the general form of a function definition that returns more than one value. So generically, we're going to call the function function name. So it's in an M file called function name. The function header starts with the reserved word function. Then instead of just one output argument, we have in square brackets several output arguments, however many you need, however many the function is going to return, followed by the assignment operator, followed by the name of the function, which is again the same as the name of the M file, and then whatever input arguments you need that correspond to the values that you pass to the function. Then you have the block comment describing what the function does, and then you have the statements in the body of the function. So somewhere in here you have to assign values to all of the output arguments. So let's say that up here for the output arguments we have two called A and B. That means that somewhere in the body of the function I need to put values in both A and B. For example, I might have them in assignment statements. So by putting values in the output arguments, that's how the function actually returns, in this case, the two values. You can separate the output arguments by commas in the function header. So since this function is returning multiple values through the output arguments, the function call should be in an assignment statement with multiple variables in a vector on the left-hand side. So if the function is returning two values, you should have the call to the function in an assignment statement that has two variables on the left of the assignment, so that you're going to capture all of the values that the function returns. Otherwise, some of the values will simply be lost. They'll be returned from the function, but you won't have them stored anywhere. Let's take a look at some examples of function that calculates and returns more than one value. So let's say, for example, the header of the function looks like this. So this is not the entire function definition, but just the function header. So we can see that we have the word function, we have three output arguments called x, y, and z, and the assignment operator, and a generic function name. And then let's say, for example, we need to pass two input arguments to the function, and it uses those values in calculating the values of x, y, and z. So this indicates that the function is returning three things. So a call to the function would be the name of the function, the two values that you're passing to the input arguments A and B. And notice that we put this in an assignment statement that has, on the left of the assignment, a vector with three variable names, G, H, and T. So the value that the function returns in X, that goes to G. Y, the second value returned from the function, goes to H. And the value of Z gets stored in T. So again, since the function is returning three values, we have three variables to actually capture and store all of those values. Or in the assignment statement, when we call the function, we could use the same names as the output arguments. Doesn't make any difference since the workspace isn't shared. So we could call them the same names as the output arguments, or we could call them different names. Here's another example of a call to the function. We give the name of the function. We're passing two values to the input arguments a and b. But notice that I have this in an assignment statement that only has one variable on the left. That means we're only going to capture the value that is returned through x. It's also returning the values of y and z, but we're just not going to get them. So we're only going to get the first value returned in this particular case. Another kind of function that we can have is a function that does not calculate or return anything. So it doesn't have any output arguments in the header, nor does it have the assignments operator. So in the function, which is generically called function name, we start with the function header, which starts with the reserved word function, but then notice what's missing here. We don't have any output arguments and we don't have the assignment operator either. We have the word function immediately followed by the name of the function and whatever input arguments we need. Then we have a block comment describing what the function does, and then we have the statements in the body of the function that do whatever it is the function does, but it's not calculating or returning anything. So the statements in the body would typically be some kind of plot or display, printing a bunch of things, for example. So that's when you would generally have a function that doesn't return anything, when it's some kind of plot or display. So when you don't have any output from a function and you're going to call the function, since no value is returned, the call to such a function is basically a statement that stands by itself. So for example, if this is our function header, again, not the entire function definition, but just the header, we can see that we don't have any output arguments, so the function isn't returning anything. So the call to the function might look like this. We give the name of the function and whatever values we're passing to the input arguments, and we could have variables with the same name as the input arguments or not, it doesn't matter. But that's basically all we can do. So here's something we could not do. We could not call the function and pass x and y and then take the result and store it in a variable. There is no result. The function's not returning anything, so this is totally invalid. Okay, we can't have this in an assignment statement. We can't have it in a print statement. It's not returning anything, so there's nothing to assign. There's nothing to print. So again, the call to the function is just going to look like a statement by itself. It's just the name of the function, whatever you're passing to the input arguments, period. That's it. It stands alone.